Our planet's very existence, its vibrant geology and stable climate, hangs by a cosmic thread. A single catastrophic impact billions of years ago fundamentally sculpted Earth into the world we know. For eons, early Earth was a molten, chaotic sphere constantly bombarded by space debris. Its rotational axis wobbled wildly, creating extreme, uninhabitable environmental swings consistently. There was no stabilizing force, no consistent rhythm dictating planetary processes or geological evolution. This primordial chaos would define our world until one monumental event reshaped its destiny forever. Understanding this ancient collision reveals the intricate dance between celestial mechanics and geological formation. It explains why Earth possesses such unique geological features and a habitable, stable environment. Scientists theorize a Mars-sized protoplanet named Theia hurtled towards the early Earth. This wasn't a glancing blow. It was a devastating, head-on impact of unimaginable scale and power. Imagine two colossal liquid planets colliding, exploding with the force of billions of nuclear bombs. Theia shattered, its core merging with Earth's, while vast amounts of molten rock and debris ejected into space. This incandescent ring of material, circling our nascent planet, defied the laws of ordinary celestial mechanics. The sheer violence of this event ejected material far beyond Earth's gravitational grasp momentarily. Yet, gravity soon began its relentless work, pulling these fiery fragments into orbit around Earth. Over centuries, these molten fragments slowly coalesced, clumping together through intense gravitational attraction. Picture a cosmic snowball forming, growing larger and hotter as more debris slammed into its surface. This massive aggregate eventually formed our moon, a silent witness to Earth's tumultuous genesis. The moon's creation marked a pivotal turning point, profoundly altering Earth's geological future forever. But the immediate aftermath of this cosmic ballet presented an even stranger phenomenon. The Earth itself was left spinning incredibly fast, completing a full rotation in just a few hours. This rapid spin created immense centrifugal forces, dramatically flattening our planet at its poles. The newly formed moon, initially much closer, exerted colossal gravitational forces upon this rapidly spinning Earth. These unprecedented forces generated enormous tidal bulges, deforming both the molten Earth and its oceans. The friction from these monstrous tides began to slowly, but relentlessly, decelerate Earth's furious rotation. This tidal braking mechanism also caused the moon to gradually spiral outwards, increasing its orbital distance. Imagine a planetary waltz, where each partner's movement directly influences the other's rhythm and position. This slowing rotation extended the length of Earth's day from mere hours to the familiar 24-hour cycle. Wait until you hear the incredible ripple effects this single event triggered across our planet's geology. The moon's immense gravitational pull began stabilizing Earth's axial tilt, reducing extreme climatic variations significantly. This consistent tilt established predictable seasons, a crucial prerequisite for complex life to emerge. Moreover, the moon generated powerful oceanic tides, stirring Earth's ancient waters, driving geological processes. These colossal tidal forces constantly reshaped coastlines and influenced the planet's internal heat distribution. The moon also profoundly impacted Earth's internal convection, influencing the very movement of tectonic plates. It played a critical role in cooling Earth's core, affecting the strength and stability of its magnetic field. And then something truly unexpected happened, as the moon slowly drifted farther from Earth. This gradual separation reduced the tidal friction, slowing the rate of Earth's rotation decrease. It created a delicate equilibrium, a perfect balance between rotational speed and axial stability. The moon's stabilizing influence permitted the consistent operation of plate tectonics, driving mountain building and volcanic activity. Without our moon, Earth's rotational speed would be much faster, shortening days to mere hours. Extreme weather patterns would dominate, making large landmasses largely uninhabitable for complex organisms. Intense storms and constant seismic activity would continuously scour and reshape the planet's surface. Expert geophysicists suggest that life as we know it might never have evolved on such a chaotic world. The moon, therefore, isn't just a beautiful celestial neighbor, but an essential geological architect. It fundamentally dictates our planet's internal dynamics, its surface features, and its climatic stability. Every ocean current, every mountain range, Every stable season owes a debt to that ancient collision. This cosmic event transformed a volatile, barren rock into a dynamic, life-sustaining geological marvel. The moon acts as a celestial anchor, preventing Earth from wobbling like a spinning top. This stability ensures that Earth's polar ice caps remain largely consistent, regulating global temperatures. Without this lunar influence, Earth's tilt could swing dramatically, leading to ice ages and superhot periods interchangeably. Such extreme geological and climatic shifts would present insurmountable challenges for sustained biological evolution. Sustaining plate tectonics. This continuous internal heating helps drive the convection currents beneath Earth's crust, sustaining plate tectonics.
So, the formation of our moon represents Earth's ultimate geological turning point, a true cosmic intervention.
It sculpted our world's landscapes, from towering mountains to vast ocean basins, over billions of years. The moon provided the crucial conditions for complex geological processes to flourish and diversify. It is a testament to the profound, transformative power of celestial mechanics on planetary evolution. The violent birth of our moon fundamentally shaped Earth's geology, climate, and the very possibility of life. If you found this cosmic narrative fascinating, subscribe for more incredible stories about our universe, and let me know in the comments what planetary mystery you find most captivating to explore next.